In our original population, we're in a lab situation where we have a total of 200 moths. Over here, we have an allele of big B equaling a black moths and an observed number of 39. We also had 112 peppered moths with the allele big B little b, and we had 49 white moths little b little b. We want to test to see if our initial population is in Hardy-Weinberg equilibrium. We first need to assume that our population is infinitely large. We have random mating occurring, no selection, meaning that all genotypes are equally fit, no migration has occurred, nor has mutation occurred. We are going to assume that all of these are true. We already found our observed values in the lab, but now we need to find our expected values. We calculate our expected values by finding the frequency of alleles that occur. Following the B frequency occurrence, we found that we got a p-squared value of 0.225, where if we multiply our 0.225 times 200, we get an expected value of 45 black moths. Our frequency for a little b is going to be equal to a q-square value of 0.275, which will result in 55.125 expected white moths. Lastly, to find our peppered moths, we take our 2pq value, and this is going to correlate to 0.49875, multiply that by 200, and we get an expected value of 99.75 peppered moths. Taking our number of genotypes, which is 3, minus number of alleles, which is 2, we get a degree freedom value of 1. Thus, our critical value is going to equal 3.84. We already found our expected value, so going through the chi-square test, we get a value of 2.93. Which is less than our critical value. Therefore, we are going to fail to reject our hypothesis, meaning that our initial population is in Hardy-Weinberg equilibrium. So now we want to see what happens to our moth population after we release it into the wild. And we're going to change our fitness value. So we're going to mess up our Hardy-Weinberg equilibrium. We're altering the selection. Well, after releasing our moths into the wild, we have a new fitness value. Our black moths have a 1.0 probability of surviving. Our pepper moths have a 0.43, and white moths have 0.12. We quickly want to find our average fitness value, which is found using this formula. Going through the math, we find that our average fitness is going to equal 0.4731. Tying it all together, we get our new frequency value for our black moths to be 0.4769, peppered moths to be 0.4524, and white moths to be 0.069. As you can see, the white moth population has decreased along with the peppered moths, and the black moths have increased because its fitness is so much better in the wild. Based on these results, we conclude that we have directional selection favoring the black-colored moths population. So, after many generations, we'll eventually see that black moths will be the only moths left in the wild.